Okay, hey guys. So if you had a situation like I did today where, for example, I needed an analog output to function more like a discrete set point sensor, and I just didn't have the functionality of that sensor built in there, so I needed to add a few logic thresholds around the PLC so that the PLC setup and all of that remained intact, and all I need to provide to the PLC is one discrete input. So in this situation, I needed to create a workaround which is perfect for something like the DXM-R50 Logic Blocks. And in that logic block, I'm able to set up some threshold rules so that I could simulate somewhat of a window type teaching functionality to the sensor. So I'm bringing in an analog input from a sensor, and I am going to create a window within my logic and create then an output. So you'll need, for this tutorial, this example, if you're working with one of these blocks, you'll need a programming cable, which is the BWA UCT900 cable, and you'll need to download this software. I will put a link to all of this in the description below. So let's take a look at the software. You'll have to connect over USB. It'll prompt you here, and for example, we could just start over here, file new, and you can either load a selected template or download whatever's in there. So I'm just going to show you how I did it. So this is my ultrasonic, oops, cancel, nope, no, load selected template. All right, so we'll just do that. And what's really cool about this is that it pre-maps everything for you in there. So you've got your two analog inputs or your two discrete inputs. This little logic block will do either or on each port. So that's really cool. You can bring in multiple signals types, and then we've got two discrete outputs that I'm able to use out of that. So for my action rules, this is a new program. I'm actually going to open up what I have, my ultrasonic test. I'm working with an ultrasonic sensor that does not have an IO-Link, I'm sorry, a discrete output on it. So what I ended up doing is, if you look over here to the ID number for my input, I'm connected to input 1 of my analog. I'm on ID 8, so I'm going to look at this register value. They have a built-in viewing simulator type register. We call it a register value table. And I can look at maybe 15 of these registers. Notice number 8, we're going to look at that. If I click read, since I'm connected, I get a value here. I don't have time to go and do like scaling and figure some stuff out. So I'm just looking at that distance value. That's my lower limit. And then I'm going to look at my upper limit. And I'm just going to manually set this up this way. And that's what I'm going to use as my upper and lower limit thresholds. So if you go here, this is your data stores, everything that's in here. You have a few registers that you can use. These are called data stores. These are basically what you would think of internal tags or local registers. Think of them in that way. You can do a few constants and counters and the register number here. Okay, so if I go to action rules, what I did was I created a lower limit. So it's very simple. It's just a threshold rule. And so I'm looking here at my drop down. I feel like Banner did a great job with making this really easy for us to understand. So if my analog input 1 is greater than, I should probably use greater than or equal to value, and I picked my threshold value. When this is true, set my local register here, my data store, to a value of 1. And the reason I'm doing it this way, I'm creating my lower bound and my upper bound. And the reason I'm doing it that way is because I need a math rule after we do all of this, just for a scenario when it might get a little buggy. So I just want to make sure that if it's within both those limits, that I'm going to have the right output turn on. So I did the same for my upper limit. There's my value that I looked at. I put it in a separate data store number, set that to 1, enabled my 4 to 20 my else, basically my else statement here. And then I created a math rule and I did a logical AND. So when my data store 1 and my data store 2 are on, that's when I want to trigger my discrete output 1. So that is how I am doing it. You could do a few other things here. There are other drop downs: register, copy, control logic, trends, and there's a few things that I actually haven't even explored yet, but it's pretty sweet. So what I do now is I do a file save and I send this to my DXM-R50, and it takes just a minute. And what I'm going to do is I'm going to test this for you. I'm going to click here on my register view, my enable polling. Oops. And you are going to see my measurement value here change up and down. I'm going to go within the limit and then outside the limit, and you are going to see my discrete output 1 turning on and off based on my window setting. So hopefully this works. Now I'm pretty happy with that. I hope that helps you. I hope that gives you options as you work through some of your applications as well. God bless. See y'all in the next video.